We are live now. A little bit boring because we're getting to set up.
Is this angle okay?
Yeah, I think this angle is.
It's or you can move it.
Everything's a B except for this one, and this one you couldn't tell. So those are like, indications all
Oh
type.
yeah. And then resolution is. So you can't tell the difference.
The resolutions are all, you can or
You
can't.
cannot.
Without the microscope.
Yeah, you cannot tell the difference.
So who besides you, who's your competition? Because the best resolution compared to forms do?
They don't focus on resolution.
Well, they have good resolution.
Decent. The laser usually have the least resolution compared with LCD compared with DLP. DLP can focus more and get a pixel in small.
Well, they have the leader,
No, it's laser. It's a fixed line source. So that's
There's laser, there's DLP, and there's LCD.
You guys are DLP based.
and then we found if we don't need LCD, then we will not be competitive. That's a future. Yes. So we have
Those
to.
get the form factor down.
Yes. There's a lot of advantages. So we have to move in earlier.
Sure.
Yeah.
So you guys do, as far as I know, the best resolution products.
Yes. We focus more on the resolution because we think SLA is the strength of SLA is the resolution. If you don't want resolution, go for FDA.
Are you familiar with Vision Tech?
Oh yeah. Yes.
They have very high resolution.
Yes. My customer, they have 3 types. I say it's very close.
If you guys want to talk, my recommendation is to be on this side so that people on the internet can hear your questions also.
So this is the prototype, right?
Yes.
How many prototypes do you have right now?
I have no idea. I don't actually work for him.
Oh,
I'm
okay.
just helping out.
All right,
I'm a backer just like everybody else. But
Fair enough, yeah.
as a backer,
You probably got one of those very earliest ones, didn't you?
no, I backed at $500. I was there.
Oh, okay.
But as a backer, it's always helpful to me to have creators do events like this.
No,
Since
absolutely.
they're local, I'm like, hey, I can help you out.
I get it. I'm local and I'm a backer as well. I got it at $2.99. So
Good. Let's see here.
I didn't get in the first 30 seconds to get the first tier.
Demonstrating the software.
You can take a look at the software here. I mean, it's got to be used. He's got to use it to run it. The software is relatively similar to the one that uses the one that runs on the Titan. So essentially, you slice external to the software. You upload the slices, and then you set the various parameters based on regions.
Now, we'll have automated settings. Maybe I'm not asking the right person, but we'll have automated settings for the different types of resin. So if there's like a resin A, a resin B, a
So
resin
then it
C.
turns out to be the easier part. So yeah, Ted Ulrich actually has what Ted did for instance, the Titan 1 is yes, he lists out the kind of the recommended default settings for all of the different for the resins that he supports. But then there also can be variation and optimization depending on the part itself. So if the part has it's like a solid cube and has a ton of surface area, then you gotta slow down. And then if your part is like a lattice or right, lots and lots of just thin shapes, small surface area, then you could go a lot faster. Mechanically speaking.
Does this software automatically generate the supports, or do I have to generate that?
No, you have to generate those externally. The software is focused on printing, support generation, and orientation is kind of a more complicated thing. So we do that.
Do you recommend software for that, or are you just using something like the B9 or?
Well, we don't use B9 because it's somebody else's software. So if you want to use it, and a lot of people do use B9 software on other third-party printers, but from the official recommendations, most people are still using the latest version of the last version of Creation Workshop.
So So Creation Workshop can generate support.
Yes, Creation Workshop can generate supports and slice, or you can use Mesh Mixer. Mesh Mixer has more advanced support generation, but then you have to export that as TL and slice using some other tool.
Okay, so this software, you're just bringing in G-code, or you're bringing in
Images.
STL?
There's no G code, or there's minimal G code for a printer like this. There's only a Z
So
axis.
this is just bringing in images, which is sending to the LCD.
That's correct.
Projects
So
it.
it generates the G code based upon the parameters you choose on lift speed and down speed. That will control the speed parameters to the G code. And it will execute the G code and turn on the light source and all of that automatically. So it will orchestrate that.
So if I come out with a design program like ZBrush, and I have OBJ or an STL, obviously I'm going to need to generate a support structure and possibly a raft, which will adhere to the build platform.
Right.
What software do I go to straight out of ZBrush? What's my first step?
Depends on how advanced you need. The easiest way is Creation Workshop.
So Creation Workshop, is that freeware, shareware?
It's freeware.
Okay.
So where should I stand?
You should stand over here. Where you can see yourself here.
So should
And this is the focus spot, so that's probably the best.
It's
That's probably the spot.
or should I move the printer to there a little bit?
Anywhere is fine.
It looks
we
good.
can see it fairly well, and then I'll move these two cameras to
It's not moved.
match. But the main thing is that is the microphone. The high quality mic is directional, so you want to stand somewhere in that area.
Okay, so and then the computer. I have a neat computer here.
As low as possible. You push the button again, and then they'll turn off. Yeah. I think largely speaking, we don't need the screen that much. This is just for reference. What we really need is nobody said. Supposedly there are 114 people watching.
Okay, are we
Yeah.
going to start?
Go to on air. Start broadcasting. Oh, sorry. Sorry about that. I thought we were broadcasting already. Okay.
Where should I stand? Here?
Yeah, there's fine. You can see yourself there, so.
Not head.
Yep, we get started. So we're here at TechShop in San Jose. We've got Ted, the founder of Kudo 3D here, and he's got the bean. What we're going to do basically is just set up the print. We'll maybe talk through what the printer does, show you guys a print running, and pretty much take questions, right? So we're not going to,
Yes.
we don't have an official presentation or anything. The focus really is, let's get the printer running, we can watch the printer print, and then while the printer's printing, people can ask questions or whatever, and we'll answer questions just to alleviate the boredom while the printer's running.
Yes, yes. So I'm Ted. So and thanks for the support that's in the last 2.5 weeks. And it's I have to thank James for helping arrange this event, so we can demonstrate how Bing works. And as you've seen, Bing is pretty small. It's sitting on the table, and this is my hand. And this is based on the LCD technology, and which we believe is will disrupt the SLA printer industry. So, so I'd like to take this opportunity to show everyone how this printer works. So it's pretty simple. I think most of you have already have an idea what's behind this printer. There's the LCD 2K panel here below the vat, and we use the drum type of vat with two flexible hinges here, so it will be similar to the action of Titan. And inside, and there's a open hardware circuits. There are a small computer plus Mega 2560 and ramps. So pretty much it's very similar to Titan 2, and we just shrink it into this little box, and we name it Beam because it's really small for this machine, and but this machine is not a fast machine compared to Titan. For Titan, we can print like in an hour. If we do a layer thickness like 250 or 300 micron, we can do an inch tall of object in an hour. But for Beam is a slow machine with high resolution, and the resolution is almost fixed. And even if we want to tune it down for layer thickness, increase the layer thickness, it's difficult. So the layer thickness ranging from like you can do 15 micron no problem, and probably all the way to 75 microns. So for this event, we only have 2 hours, so it's very hard for us to pick an object that you can actually see it grow. The container is almost like 2 centimeters tall, so you won't see anything, before 2 centimeters. And so we do the 75 micron layer thickness to speed it up a little bit, and some kind of simpler structure, so you will see something pull out from the liquid. And now we are going to start, and so currently we are using the you can see the software. It's very similar to the Titan software. You can actually download our Titan 1 software, and you'll get an idea of what the machine can do. And so now I'm going to pour the resin in. First I'll lift up a little bit. So you can see that this is flexible, and then there is a home button in the software. So I just press it, it will all the way going down. And then there's a sensor. It will stop right away when it touches the sensor. And that's it. Then we can start. The files are loaded, and let's start with this one.
So you guys in the room, you guys don't need to stand way back here, out of view. If you guys want to go for a closer view, go ahead. You can't block the camera because
Okay,
the here.
it's start printing now, and it's hard to tell from this resin because it's really black. It blocks all the light. If using the translucent green resin, we can see a little bit of light coming out, but not for the black one. And can I get tissue paper? So can they see it?
And they probably won't see it clearly, so.
This is just the attachment layer. So it takes us to make sure that the first layer is usually much longer. So, well, let's just wait.
Who is your target market for this printer?
The target market is actually for Kickstarter is a different group of market. So for Kickstarter, it helped us to jumpstart this project, and at the same time it has a marketing purpose. So after Kickstarter, we're focusing on more like not the professional, but maybe like schools or like education or those kind of can start with a cheaper printer. But for the professional, like a very high resolution, or someone wants to print very big model, those type of printer probably will still be a lot more expensive than a regular one.
Are the materials generally safe, or what are the issues with toxicity?
Toxicity. You need to have a room with venting or air circulation.
Okay.
Yeah. So that's the only requirement. But you can't eat it, of course.
You can't eat it?
No.
You can make beans, but you can't eat the beans.
Maybe for the biocompatible resin, you can bite it.
So do you think, is it safe for kids, or is it more like a professional?
No, it's not for kids.
So schools above?
Schools, okay.
Above high school or
schools,
something?
those are fine. Yeah, but not for kids.
Not for grade school?
Yeah, some yellow resin looks like juice.
I don't mean that young.
Yeah.
Generally speaking, for all of these, the chemistry in these resins, once it's fully cured, the acrylic is really, really inert.
Yeah.
But if it's not fully cured, the photoinitiator is pretty reactive, and that's the hazardous part. Right? So if you process it fully, in theory, and this is how like medical applications they do, right? And you go through your process and make sure that it's fully UV cured, then you'd say this thing is pretty inert. It won't harm you. But for any kind of general purpose, regular people, right? We can't validate, certify that you did it the right way. So generally speaking, it's best not to use it in circumstances where you might end up eating it or if you're contacting food.
Okay. So on the Kickstarter, on your Kickstarter, you can buy this with and without the curing device.
The lamp?
Yeah.
Oh, you can cure it under the sun if you want. That's fine.
Really?
Oh yeah, sure. Yeah, only like half an hour should be done, especially in California.
Okay.
So this is a UV curing resin, right?
Oh yes,
yeah.
yes.
So-
UV.
Or close to UV?
Close to UV,
Close to UV?
purple.
So does the cover here actually block any UV light? Is that the
Oh,
green acrylic cover?
This is blocking the UV light.
Yeah, it does. The green blocks the UV light? Okay.
Yes, and blocks the purple light.
So,
Okay.
Yeah.
so if the sun is about to hit this, you want to make sure the cover's on it.
Oh yeah.
If the sun hits it,
Yes,
it
yes.
could be a problem.
So actually, the room actually we're protecting the resin from this kind of light.
Yeah.
There's a lot of UV.
Sure.
Yeah.
Okay.
You have to go through a process where you level the machine.
Level the machine.
A bed
Oh, yeah, there are
level.
four legs. Yeah, actually, you need to do that when you get the printer.
How do you do that?
Oh, usually I check the level here. If I have resin in.
Okay. And then if it's not level.
And it's even more accurate than the dark bubble because it has the length is much longer.
Okay, but to level it, do the feet have some sort of screw?
Oh yes, there are four of them.
So I'll just level it by eye
Yeah.
according to the resin.
The resin level, yeah, it should be pretty accurate.
Okay.
Does leveling it really matter much? Isn't it what's more important that the bed is, or the platform is level with the LCD?
Yes,
It doesn't-
that's more important.
That's more important than anything else.
Yeah, but
I
it's
mean,
tilting too much.
if you tilt it too much, you're gonna pour the resin out, right? But if it's tilted
Yeah.
just a little bit, as long as the resin's inside the container.
Yes,
you're
yes.
fine. Okay.
Yes. So when we had one time we don't have enough resin inside and it's tilting too much. Then close to the end we don't have resin anymore because it'll go to the one side of it.
So, yeah, that's a question. If you start to run out of resin during the middle of the print, you can just take the cover off and add a little bit more resin, or how does that work?
Have to be careful doing
Sure.
this. It has to be like when it's not when it's lifting,
Uh-huh.
and then you can pour in some resin, but you have to
Okay.
stop it because if the liquid is still moving around and then you
While it's trying to
lower
cure,
and it's
yeah.
not stabilized.
Okay,
First of all, there is a problem. You might see a line.
Yeah, okay,
Yes.
that makes sense.
Yeah.
Can you pause the print to then load more resin in?
Yes, but not don't post too long because you will see a line too. It will keep shrinking the existing one.
Those model print with this machine?
The one in the boxes, they are printed by Titan.
Oh, the one in the
Yeah, not the one outside the boxes. They are printed by me.
Do you have any castable resin yet?
We are testing a castable resin.
You were testing it?
Yes, we're testing from several suppliers.
Have you tried the B9 Emerald?
B9, it will be very, very slow on this machine.
Very slow.
Yeah, B9 is already slow. So this LCD has less power than like Titan, so it's even slower.
Do you know how long it is for
Oh,
color?
It will be very long. The curing effective curing intensity for the bean is about 1/5 of Titan.
1/5.
So it's very slow. And in order to speed it up, we have to add more like a photo initiator to speed it up.
To the,
But
you mean
to-
add it to the resin?
Yes, to a certain degree. And it can't do too much. So it's still slow. And we can speed it up by putting more LED, but it has a heat problem. So this is the first generation, so we have to see, if it's like everyone said that it will severely degrade LCD. So we don't want to put a lot because if that's the case, means it's not linear. So whenever power you put on the LCD, it will decay a lot faster. Yeah.
So this one, it have an LCD at the top here, right? And then the light at the bottom.
Yes.
And the LCD just made the shape of the layer.
Yes. And so just a purple line coming out. You can see there's a purple. Yeah. You can see it's purple, pure purple.
I see. Isn't that like better than the projector one though? The purple one? The projector?
Better than
The
DLP.
Oh,
type.
that's DLP.
So the DLP is stronger than the purple light?
Oh, the light is much stronger.
Stronger.
Yeah.
So I think probably the big question everyone's curious about is, how does this compare to kind of your competitors in this space?
DLP or LCD?
No, I mean this particular, the LCD.
Oh,
How does
LCD.
this compare against some of the other LCD
We're going
resin
to.
printers out there?
No,
I mean, 'cause-
in terms of performance, I think we are at least as good as others, and then we have resins tuned for this machine.
Okay.
And Also, then it comes to the brand, the service,
Sure. Okay.
and all the documents,
True.
supporting document, all this kind of thing. Yes.
Okay.
Do you know how long does it take to print those rings right here?
Which one? That one, oh, that one is long. That's 25 micron layer thickness. So, and then that's a very big area. We have to overexpose a little bit. That one, I think it takes 10 hours.
10 hours for this one?
Yes, because the center is stronger. And surrounding is, so we have to overexpose it.
I see.
And but the resolution of this resin is good. So even if you overexpose it, it's not like Titan. The size doesn't change that much.
You mean the dimension?
Yeah, dimension. Yeah, it's not that sensitive to the intensity.
Is this black or like?
It is black.
Black.
Yes. And this is the black has the highest resolution. We have 4 colors, and unless we add UV blocking, but for this resin now we don't want to make it complicated. So black is the with the highest resolution now, and usually red also give very high resolution.
What about the other ones? So what about yellow? What are the kind of the
Those are-
like
those
which each resin for?
Those
I
are
guess?
pigments. So
Sure.
so pigment usually gives a lower resolution because they're powders and the light will get dispersed.
All right. So black is the highest resolution.
But they're a good side,
Okay.
When the resolution is high, the surface lines, no layer, is so clear. But like the gray one, it has a little lower resolution, but the surface tends to smooth out by itself.
Okay.
Yeah, so it depends like
Yeah, it depends on
application.
the application.
Yes, yes.
So what all cleanup steps are there after a print is done?
Should they?
After a print is done, what all cleanup steps are necessary?
And you have to soak it into the alcohol, IPA, and probably like 2-3 minutes.
Okay.
Yeah, and then post-cure it.
Okay. So just put it in a UV.
Yes,
Right,
and or under the sun.
Okay.
Yeah. Yeah. So
How hard is it to get off the platform? Do you just take a spatula and crack it off?
I
or just
use a blade.
a blade? Okay.
Yeah. This is a small platform, so usually you just use a blade.
Okay. And which replacement parts would we want to have on hand if we were giving one heavy use? Like what should we expect to need to replace first? Kind of
The film, Teflon film.
the Teflon.
Teflon film.
Okay.
There's a film at the
Yes.
bottom.
Yes. So so this machine has a lower maintenance cost compared with the laser or DLP. Yeah.
So how long should we expect? From when we first unpack it to the first service, should we have parts on hand already, or like how often should we need to expect to do maintenance on it?
The film probably you need to replace it. Depends what you are printing. So probably 20 or to 50 prints you have to replace it. Yeah.
Okay.
And it's very simple. You just take the screw out, put the film, and put it back. Yeah.
Okay. Cool.
How do you know when you need to replace the film?
Really, it depends on your need. Some people print like engineering high precision. Then their tolerance for the film deformation is very low, so you have to replace it. But a lot of miniature, they don't care that much.
Okay. All right.
How well sealed is the machine? If I spill some resin on it, then I have to be worried about the resin's going to break down into the electronics.
The resin the resin is not conductive, so usually from our experience, the resin will hurt only when drip on the optics, because it cure on the optics. But for the electronics, I don't think it will hurt because it just cover a layer, even it cure. It's not conductive.
And if I get anything on that LCD screen, some resin, what do I clean?
There is the screen on top. It's like a foam. There's a protecting, and usually after it cure, I think you with plastic or something you can remove it. If it's not cured on it, you can just use the alcohol to wipe it.
So isopropyl alcohol won't damage the LCD?
No. On top there's a protector.
Protector.
Glass. There's a glass.
Okay, so there's glass, then the LCD.
Oh yes.
Okay, understood.
Is there anything else other than the Teflon at the bottom of the tank? Just the film?
Actually, this machine is much simpler than Titan. So even the zero, it's automatic. So there's no calibration.
No, I mean at the bottom of the tank. Is there anything else other than the film?
No.
Like the Titan, you have like a.
No, you can't have anything. Because the light will disperse, so it's better to be as close as possible. So that's why it has to be a film. It has to
So
be a
the film and then glass and then LCD.
Yes.
Could you talk about the software that's used? If I have an STO or an OBJ from an application like ZBrush, what are the processes for me to generate the raft, generate the supports, and then slice it, and then send those sliced files to the printer?
Okay, so the process would start with exporting the file into a STL format, and then we can process that file. We can check if there's any error on the file, and we can hollow it using a mesh mixer, and we can add support. So with mesh mixer or creation workshop. And so with the supports and then we just slice it, using creation workshop, or there's another one called laser, and then we wrap all the slices into the zip file and upload to the printer. So the zip file will stay inside the printer, and also the printing parameters can be saved inside the printer.
How is the zip file sent over? Is that through an SD card, a USB cable, through Wi-Fi?
It's like this one now is a Wi-Fi adapter, so it's not on the internet. We're using it as a.
If you guys want to sit here, you can sit here too.
Oh, so that has an internet connection?
No, but you can put it on the Ethernet. You can use it as a repeater, but now I'm using it as a standalone router.
Okay.
So
if I just have my laptop, though, I can go from a USB cable.
no,
Well, then that's
no, it's all wireless.
It's all wireless. Okay.
It's wireless, and so you can use any computer or even your cell phone.
Okay.
So
I set up a Wi-Fi connection.
this is Wi-Fi, but it's not on the internet.
Okay.
So the computer talk to this, and this has a cable connect to the printer.
Because there's a computer in the printer. One of the things about these DLP projectors is that there's both the USB control for the motors, and then there's also a video output for the screen. And when people use their computers to control the projectors directly, you have all kinds of weird problems with like Windows dual screen mode and accidentally projecting mouse pointers into the resin and stuff like that. So to avoid all those failure conditions, there's a computer in there, and you have to connect to that computer
Yes.
over the network.
And the good thing is you can remove this computer. You don't need, once it's started.
Okay. So the Kickstarter that I backed was the $299. Will that have all of the communications hardware for my computer to talk to it if my computer has Wi-Fi?
No, you have to get this thing.
You'll need like a Ethernet hub
Or-
or something.
or-
It's a wire that can like
Or just you plug this wire directly to a router.
Okay, so the Kickstarter that I backed still needs additional equipment for the printer to talk to my
The printer has a
It has an Ethernet jack
in the
on it.
back.
as an Ethernet jack.
Yes.
So okay, so
It's
I
plugged into a wire.
can go from Ethernet from my computer directly into the printer.
Directly, no. No, you
Yes,
have
if
to
you
go
use- If
through.
you use a null modem cable or
Crossover.
a crossover cable as possible, the easiest way
Right.
is you have a switch or a hub or whatever
Yes.
you have and plug your computer
Okay.
in this in.
So it requires a switch and an Ethernet cable.
Right. Or if your Wi-Fi is at home, your Wi-Fi router, usually most Wi-Fi routers have a couple of Ethernet jacks in the back, and you plug this into one of those.
And your instructions would go through how to set that up.
Presumably.
Yeah. So you can put it on the internet, or you can do it like here now. It's that standalone, so you can carry it any place you can print.
Are you the designer of the hardware? Are you the engineer that designed this?
Oh yeah, our company designed this, and it's pretty similar to Titan 2. You know.
I mean, you personally.
Oh, I involved. We have
You're one of the
several.
you're one of the
Yeah. We have several engineers. Yeah.
All the engineers work for TED.
What's your
I don't work for them. I'm a backer.
I'm
free t-shirt today?
This is
No,
from
wait.
when I backed the Titan 1. I got this t-shirt from them.
I'm local to the Bay Area. Will you have a will call if I need supplies and I come to your office and just pay for a bottle of resin, or do I have to purchase that mail order?
Or are you gonna stock it here? You're gonna stock it here?
Yeah, because there's so many people, so yeah, it really depends. You can contact us, yeah, and if we have have time, of course we're welcome. Yeah.
Okay.
I don't know if you guys saw the video that I made when I went to their office last week. The office isn't really set up for retail.
Well, most of all. I mean, is it just on Amazon? Where do you get the resin from? Normally you have to campaign this over.
Mail order from these guys.
Yes, for in the U.S. you will be mailed from our office, at least for now, and it is possible we'll do the Amazon, but we're still evaluating. Yes.
So how about picking up the Kickstarter rewards? So if you are local, well, can we pick them up at your offices rather than
Yeah,
have them
you
shipped to us?
can you can call us. And,
Okay.
Yeah.
Great.
No problem.
Okay, awesome.
Is the shipping gonna be on time now? Like,
What?
the shipping
Shipping?
date, is that gonna be on time this time?
Hopefully,
Yeah, because last time I think it's a little bit late.
2 weeks. We shipped the first one 2 weeks late.
2 weeks late.
Yeah.
Not that bad.
No, but the shipping period extend like a month and a half. Remember?
When are you planning to ship?
January. Yes.
And how long do you think shipping will take to get out to everyone? Like, is it going to be like 50 a week, 100 a week, 200 a week? I mean, it's
No,
just a guess at this
it
point.
can be like that. For example, if in the U.S. we'll do a container, and
Gotcha.
and then we'll ship it off like in a week, everyone.
Gotcha.
Something.
Okay.
In Europe, probably it's the same. If you do the drop shipping, and Japan, those are with country with bigger volume. But for like other countries, then
Sure.
just
I understand, but
Yeah.
like there are some Kickstarters that take months to deliver all the rewards, so that's,
No, we
Okay.
yeah,
Great.
we'll plan for that,
okay,
Yeah.
great.
Do you have the extra resin tank that we can look at?
Oh, this is the only one I just bring. And this is only a prototype. It will be a little bit different. Because the final version will have hand screws. We'll replace that with hand screw. Yeah. And then you just remove it and take it off.
So the film gonna be like attached to like two plates. There's another plate on the wall.
Which one? The container?
Tank?
No,
Is there a
there's
plate?
no plate. It's only film.
No, I mean how does the film gonna attach to the tank?
Oh, it's the screws. You see, they are all screws surrounding. You see, these are all screws.
So you have to unscrew all those.
Yeah, take 10 minutes. I'll take you 10 minutes to replace the film.
If I do a print on this, like a class ring, for example,
Mhm.
and I have resin left over,
Uh-huh.
can I use that resin, or does that resin have to be disposed of?
you can reuse it, and but usually we recommend like when you keep recycle, and then after a while you have a bottle 1/3, you need to mix the new one. Otherwise the printing parameters might change.
Will that resin tank ship with some sort of lid?
Lid, we are thinking to design a lid, and you will think about this one, yeah. And it's in our the stretch goal now.
Are you getting any input from companies that have a lot of interest in 3D printing? For example, Pixel Logic, which makes the software ZBrush, which is used by a lot of toy designers and jewelry designers. Will you be touching base with them to get their feedback on this, or
yeah, if they can give us endorsement, that would be great. Yeah, we can contact them, but they are a big company.
What about the user group you talked about?
There's jewelers like Tomas who might be interested in this.
The jewelry design, they told me they more likely use Rhino. Rhino to design the jewelry.
Yeah, that's Rhino is used often for jewelry. That's correct.
Yeah.
Rhino, and then I think it's Matrix, which is based on Rhino.
Metric is built on top of Rhino.
I'm sorry?
Metric is using the Rhino function.
Yeah.
Like it's built on top of Rhino.
Yeah. But there's a lot of people who use ZBrush now.
Oh yes, but it's a lot harder. You need
Depends
to
on what
know
you're trying
how
to
to
do.
scope.
So are you marketing this to Rhino users, to ZBrush users, the people that would?
Yeah, if they're interested in jewelry design, they can use it. So we are developing a castable resin now.
Oh, you're developing a
Yeah,
jewelry
without
specific-
without castable resin, they probably won't use it. So we have to get that resin
Are
first.
you not sure if you're going to be able to develop it?
Well, yeah, we're doing it now. Yeah.
So it will be good for jewelry design.
Yeah, it will be, and that's a trend. Yeah.
Yeah.
Using LCD is a trend, and we believe in a few years probably all the SLA will be replaced with LCD. It's very likely.
How long is the LCD rated for? Do I have to worry about anything like dead pixels?
Pixels? No. The size of the pixel is fixed.
No, but dead
And-
pixel, what if it?
Dead pixels. So in the manufacturing, they should have a define of you know, maybe there's, I don't know, maybe one sometimes, but
If you do have
there's a
dead- If you do have a dead pixel, can you see it in the prints?
if you are printing very tiny, you will.
Like, let's say you have a very smooth surface.
Very tiny thing you will, but if your resolution of the print is not that high enough, you won't see that. Yeah. So you can see the steps, all the pixel steps. So if the resin has a very high resolution, you will see that.
If I have to glue two pieces together, can I do like I would with other SLA printers, which is just use the resin and expose it with an ultraviolet light?
You mean
for
glue two
elevation?
pieces together? Then there's a line, unless you can make them seamless.
Oh, yeah, but he's asking if the resin can be used as a glue.
Sometimes things won't fit on the print bed.
Yeah.
but it's not stick very well.
If you cure it though, you
yeah,
cure
that-
it.
I cure it, it still doesn't stick very well.
Though-
So,
though-
the middle, the light doesn't get to it.
The,
You need a bright light then.
yeah, those are formulated for printing, not for UV adhesive. Yeah. So we try a resin from a company they used to make adhesive. So when we print it, you can hear the vet coming out. loudly. Yeah, too sticky. Yeah.
What's the build area again?
The build area for this one is 12.8 centimeter by 6.8 centimeter.
Oh, do you happen to know what that is in inches?
Inches. It's a 5.5 inch smartphone size.
Okay, it's like a smartphone screen.
Oh yes, 2K. Yeah. That's the only way to coast down. Use the existing panels.
Okay, and that goes up about what, 8 or 9 inches? The z-axis.
Oh, z-axis, no, it's like 6,
6.
close to 6 inches. Yeah.
Now, because it's an LCD,
Mm-hmm.
there's no problems with distortion as you get towards the edges of the display. Like
No distortion, but the intensity uniformity is still, weaker in the surrounding. Yeah.
Okay, so ideally, I would want to have my model in the center of the display.
Oh yeah, if you want to have the resolution we track is probably it's all the same because it's fixed by the pixel, but the center has higher intensity, so your speed will be faster too.
Okay.
If I were to make a model of let's say a building,
Mhm.
like a 10-story building with no walls, but just flat, something a little bit like a building, like,
You mean struts and floor?
yeah, but without the walls, a building without walls.
Uh-huh.
The first floor is going to be flat.
Uh-huh.
The second floor will be flat.
Uh-huh.
But as we go up, are they going to be a little bit more, have some distortion? Or basically, it would be an accurate architectural
I
model.
think if you are using a new film, then it should be fine because it distorted because I think the film is starting to get warping. Especially when you print very big, like square or something, and you print a lot of times, then it start warping, and then you might see some distortion. Otherwise, it's very flat.
So if you have a flat, a shape that's undistorted, but you're going to cure it, does curing...
Oh, curing could.
Will cause...
It depends on the material and the shrinkage of the material.
Okay.
Some of the like we print like Eiffel Towers with a lot of materials, like the early material like maker juice, the struts will detach from the floor after a while.
But this won't, that won't...
No, this one won't. We test it. We print Eiffel Tower, and this one won't.
Okay, next question. Any prospect for a clear or nearly clear?
There's no problem to make clear, but to make watery or translucent like water clear, it's more difficult because the photo initiator is absorb like purple light, so it tends to be yellow. So usually it's a little bit yellowish.
So if you want to make glasses, they're going to be sunglasses.
Yeah, something, yeah.
But you could make a lens, you could make a yellowish lens.
Yellowish. I think we can, but you see for these layers, one layer, the surface usually you have to post-process to make it really shine.
Yeah, but with a lens, you can certainly do that.
Yeah.
Yeah, if you wanted to polish it, it should be possible.
Yeah.
Is the film like a drum type?
Yeah, it's a drum type.
Drum type.
Yes, it
After you screw it, it will just
and
tighten itself.
yes. The screws will tighten it.
Because I see some other tank they have like a frame to push it out.
Oh, it is a frame, but that frame push up through the screws.
So there's like a frame at the bottom.
There's like a O-ring.
Oh, you're talking about...
Yeah, something like.
That's how I...
Is that a gasket? Yeah, maybe you can say it's a gasket. Yeah, only. But if for some reason you poke it, no, not really a hole, just poke it, and the dent comes on it. And after a while, you might get stressed and start leaking from that hole. But yeah, this is acrylic. This is acrylic. No, resin actually won't react with acrylic. Glue? No, there's no glue. No glue. It has because we need to do that silicone first, and then so it needs special glue to put the Teflon.
I'm thinking for students.
The tank itself is like one piece, right?
Of the surrounding is one piece. Yeah, but there's a ring on the bottom.
How do you clean that? Black, yellow resin.
You clean the vat container, or just pour out and you can rinse it with alcohol. Yeah, this one has no problem. There's no glue inside.
The acrylic might crack with
Depends on the quality of the acrylic. Or you just use the soap water. It will be fine. Soap water will be mild. Yeah.
If you ever go for a cat steak or something,
and the thing is just attached to the bag.
and you can take those slices and you can create models
And for the light, the LED light,
skull.
if I want like a skull or like this, can I upgrade
Most
it?
recent thing I've been studying
No,
is
because that's
start going into science fiction.
each printer has their own design of the lamp and the position of the chips. It's not just one LED. There are so many chips on it, and how you lay them and make the light more uniform. And there is some layout on the lamp.
So it's not like
And no, it's not a regular LED lamp. No, it's a customized. Yeah.
San Jose State Maker Fair.
because
You can try something, but I'm not sure if it fits in. They're different. You see, the voltage may be different. They're all different. Current is different. So even you need a different adapter inside to convert. Yeah.
because I want to use it with the B9 or you said it's taking too long.
Yes, and then I don't recommend you pump it up too much because at least for now we need to validate how long this LCD. If you pump in too much light, it could damage. Yeah, damage the LCD.
Do you have like an hour for the LCD light?
Huh? Excuse me?
The LCD light, how many hours?
The average from the manufacturers giving us 10,000 average. Oh, that's LED. Usually it's more than.
No, LCD.
Oh, LCD, no. LCD, no. Manufacturer doesn't know how long it will survive under 4 or 5 nanometer. On the purple light, it's designed for the RGB. Yeah, not for 4 or 5.
They've changed.
Also, it's not like a black and white.
No.
So it's color.
It's called. So so the efficiency it's not as good as the gray one you mentioned, but you can find the gray one. There's no supplier making this type of.
And this LED, you can shine the light through.
Especially if
Yeah.
where to make sure that where he advised the students
Well, this is a slow print.
this.
So we're trying to make it affordable.
It's not just so foldable. We don't want to pump it too fast. Then, if the lifetime is too short, and it's also not a good product. Yeah. So and for this kind of price, we're not shooting for like a production type of or industry type of customer. Yeah.
Can I see the software?
Oh, here, it's here. It's the same. Currently, it's the same as Titan 2, but we're trying to make it into like application oriented later on.
So
And then
do you have to set the layer exposure time?
that is for the advanced mode.
Oh, there's an advanced one, and there's
This is
also
the-
like preset one.
Preset one is here. For example, preset one we can only do with certain resin, with certain application. That's fixed. Then we can preset numbers. But if the user wants flexibility, they want to clean all kind of stuff, then it will be hard. Hey James, is there anyone asking a question?
What?
Anyone asking a question?
Yes, there's a lot of questions. So whenever you want to take
Okay.
pause the
Maybe I should come here too.
live. Look, I'll make them big on the screen for you, so you can stay. So you guys can stay in front of the camera.
So usually how?
So let's see here. Here's bigger. Let's take a look at the YouTube live questions. Yeah, so I think there's a question on whether the screens will be user replaceable.
Oh, you will be. But you still have to remove the cover.
Okay.
Yeah, and it's not plug and play from the outside.
Okay.
What do you need to remove?
The case.
Oh, the case.
The case, yes.
Will you print a tolerance test? Because I asked you the same question on Twitter essentially earlier this week.
0.5 millimeter and gap with that kind of depth, it's very difficult.
Yeah.
Yeah, I have already tried, and I print one actually, and it will get some gear like partially stick on the side, but I still can make a move.
Yeah,
And break it.
that's the minimum to make it move.
Yeah, yeah.
When I started with when I made that on the Titan, I started with 0.5
Yeah.
and it was okay. I only got it down to 0.2 for the STL I sent you after I added a bunch more pigment myself into the resin. And then,
I can show you the one. Yeah, it's kind of it's not very smooth.
okay, and then we have a couple of questions here online. First one, how much will the FEP film be?
The film,
Yeah.
the future retail price is $7,
Okay.
and we have on Kickstarter it's $4.
Okay. So you'll let people
And
add
but that's
films if they want.
perforated. We'll put the holes in.
I see, with the holes pre-done.
Yeah. Yes.
Okay. Next. So this question is more around the tensile strength of the parts from the printer. So this guy's making gear wheels, bearings, casings. What's the stiffness and the rigidity? This isn't really a feature the printer does. It's more of a resin
It's a
question.
resin. We release like resins like with different degree of strength. So really depends on the applications. And for the really for the like miniatures figurines, we tend to use more harder type of material.
Right.
For engineering type, then we will make it a little bit tougher.
Right. But I think we talked about this last week. You haven't actually sent the resin to a lab to be tested yet.
Not yet. We're still tuning it. So everything here, including the resins, they are all prototypes.
Right.
And the resins at least we have measured like resolution, like precision. These are actually very decent compared with the resin from Titan. But it's not yet as strong as the one like engineering resin or dental resin. We haven't get to that point yet, so we're still developing it.
So then we got a question about the shipping weight, the shipping cost, whether or not you'll know enough about the weight of the item in order to know what the shipping cost or a maximum range for the shipping cost before the campaign ends.
But that depends on which country, which region. Is this in the States or?
Not sure. Maybe if you have like maybe a couple of sample countries or something, you might be able to answer this question.
In the United States, we just check the FedEx ground. So for one printer, it will be below $60. That's for one single printer, not a bulk rate. So we have to negotiate a bulk rate to bring the. That's to New York.
Right.
Yes, from California. And for Europe, we are we are doing like a research and asking quotes. So hopefully next week we will have a number for our European backers.
So I think this may be a good question back out to the Kickstarter. There's a lot of people have asked this question. If anybody has any ideas, has bought from Kickstarter before, and has received items in Europe from a reliable dropshipping company, Ted would probably be interested in hearing.
Yeah, James recommend Amazon. So we actually doing a lot of research on Amazon dropshipping.
So let's see, question about resins. How wide of a range of resins do you think you'll have?
Wide. So our current plan is for the basic type of resin, we will have different colors, but the material quality will be similar, and the shrinkage is lower and it's harder. And for the engineering type, we will tend to make it more tougher. And this will be similar resin for the dental. Usually they want tougher material and maybe resist a little bit temperature for dental one. And by nature, all these resins have pretty good resolution. And this is the nature of LCD. If you want to make a layer thickness 200 or 300 miles, that's impossible compared to the DLP. So by nature, the best is 50 micron thickness. So it always has a very decent resolution.
So question, Eiffel Tower test, how long did it take, or roughly speaking, how long would it take to print 25 millimeters or 1 inch?
1 inch, how long?
Yeah.
Depends on the layer thickness.
Let's say 50 microns.
50 micron, and also structure. So let's say it's ranging from, I would say 1 centimeter per hour, or maybe start with 0.7 millimeter per hour. To depends on the structure. You can get 1.5 or 2 centimeter per
So
hour.
let's say something easy like Eiffel Tower.
Eiffel Tower is not easy. Eiffel Tower takes much longer because the floor.
Because The floor.
The floor, yeah. Because the floor, we have to slow it down there, and the rail. The rail is very delicate. So we have to slow down, otherwise you tear the rail apart.
Oh, because the railing. What
This
about
rail is
something
very
like
tiny.
that mathematical sphere, the one you printed?
Which one?
The sphere
Uh-huh.
that's hollow, that the math professor.
Oh, we haven't printed that yet, but that should be an easy one. That's compared to Eiffel. Eiffel Tower is one of the most difficult.
I see.
Yes.
I have a question.
Go ahead.
When I get this, it sounds like it isn't just the printer that I will need.
Mm-hmm.
It sounds like there's some things that I will need to have my computer talk to the printer, and it sounds like there's some software I will need to download. So I'll need an Ethernet switch, I'll need 2 Ethernet cables, I'll need to get some sort of knife or spatula to remove things from the build platform. I'll need
That comes with the printer.
that comes with the printer.
Yeah.
I'll need isopropyl alcohol.
Alcohol, you have to get it.
Okay.
Yeah.
I'll need to have mesh mixer in
You can
order
download.
to generate, and that's a free software.
Yes.
And what is the software that controls the LCD panel? You provide that?
Oh, that's inside already.
That's inside, but how do I get it onto my computer?
The browser. You open the browser and connect to it.
Okay, I open the browser and connect to it, and
Yes.
the software is there.
Yes.
Okay, besides the things I listed, the Ethernet switch, the cables, the isopropyl alcohol, and mesh mixer,
Mm-hmm.
and of course a UV lamp to cure it.
Mm-hmm.
Is there anything else?
Mm,
Paper towels.
You might not need the UV lamp. A lot of people just use sunlight.
yeah.
Yeah.
So then you're easy. I don't know, what else do I have?
I think
To be honest,
that's it.
like if you print a lot, there are little things that do make it easier to clean up or other things. So for me, when I print, I have a bunch of these plastic razor blades. They look like steel razor blades, but they're plastic instead. So I scrape stuff with that. Spatula, like a silicone spatula, a soft one. If you really want to get the resin out of the
Back in the
tank
bottle.
easily, back in the bottle, that's pretty useful. You don't have to, right? But
So if I'm going to let this printer sit for a while between prints, I'll probably want to clean the resin out of the tank and then clean the tank. If I
you don't have to. I've left my Titan one. I have left resin in there for weeks.
Okay.
And like I have a top-down printer also. The resin, you never drain the resin in a top-down printer. So you don't have to. As long as you keep the cover on, you keep the light on.
Okay.
So, do you have the thickness of the film?
Thickness of the
Some-
film,
yeah.
125 micron.
125.
Yes.
Because some printer they usually didn't want it go out, like it worn out very fast.
We have tested. It doesn't make that much difference. The thinner one will actually slow it down.
The thinner ones slow down.
Yes, because it tends to be more flexible. So you stretch more.
You have to
So you
lift
lift
higher.
higher. Yes.
And what are the testable resin that you test already?
We're testing one from Japan.
Oh, from
Yes, and then it just started yet. Yeah, still need to make some iterations for tuning.
Oh,
Yeah.
so that's the only one you tested.
Yes. Yes.
What is the like? Do you have any idea what else you're gonna test?
We probably will test with the other supplier, but not after we get a result with our Japanese supplier first. Yeah.
Do you know about the Maker Choose back? Do you back test?
Yeah, we haven't tried that yet. But
So,
even we try, we have to adjust it because if it's not going to fit in the bin.
Because
For
of-
every DLP resin, it's not going to fit here directly. Have to modify it.
you have to modify.
Yes.
I see.
Unless the DLP is powered by LED, then that
But,
may be compatible.
In Resin Tech,
In Vision Tech, I'm not sure if their machine is powered by LED. Probably not.
I heard it is the bigger one, but I'm not sure about the small one.
It's virtually impossible to buy that resin unless you have one of those printers, though.
I saw some like jewelry tool supplier, they sell it. I'm not sure if we can just buy it. I never tried because it's too expensive.
I want to say Steve. I'm not sure.
So what are you printing right now?
No, that structure, I'm not sure if it's thick.
Did it fall off the top?
Sometimes it fall because this first layer. Can't tell, it's
So ideally, this is going to be 50 microns XY and 50 microns Z. Is that the sweet spot?
50 micron XY.
Yeah.
And this one is now is 75 Z.
Okay. So you're printing faster.
Yeah.
Z is variable. I mean, what's the lowest Z you can do?
I think we can do 15, 20, no problem.
15, 20.
Yeah.
I mean, because like for traditional laser-based SLAs, the expensive, big 3D systems, Stratasys ones. The laser has a curve width of something like 250 microns, and so what they do in order to increase the net resolution is they run the printer with like a 5 micron, 10 micron layer height, and then that's why people then kind of print their parts at an angle, because then that increases
Can you
your
pause and
net.
check it?
It averages out that resolution across the.
It's,
across the and so that's where then it's a little bit complicated.
We can pause
interaction
it.
between the X, Y,
But when you-
But this
and
is on
Z.
this one
But they
is
don't need to be the
underexposed.
same. There's no particular
So I-
special
I
advantage
probably
of
won't
having
stick with
X,
that.
Y, and Z be the same, unless for
So
some
we-
reason
because I
you
need to
want
speed it up,
to
so I
see
underexpose it.
cubic pixels
To
on
reduce the
the
exposure
part.
time.
No, but for something like this,
How much longer?
if you're doing high resolution, it
So you
might
see
make
this one's
some
3.5
sense to
centimeter,
angle it
and then
insert.
I printed
So
once
run
and
these
get it
50
done in 2
microns
hours.
XY, 10 mic-
But this is
you
simple
could go down
structure
to 20
with
microns,
75 micron
Z, and then angle it.
layer
In theory,
thickness,
yes.
and also
This is a
reduce
somewhat
the
controversial
exposure time
issue depending on which printer manufacturer.
to maximize the speed.
So there's some guys who
But the
say, yes,
software
it makes a
have
huge difference,
the
and because of
option to
that,
pause and reprint.
Oh, yeah,
put
this is here.
focusing things onto a printer that can
Pause,
get down to
yeah.
24 microns XY through optics. But the casting process isn't that precise. So
You
it's
should be
hard
able
to
to see
say
it.
whether or
Very
not
soon.
that difference is going to make a big difference. I'm not a jeweler, so I don't know. There's some controversy there as to how much of a difference that makes.
Now, I had asked previously if the company was
I
going to
don't-
get in touch with companies like Pixelogic
Do you see
or
anything?
people who were well known onto Pixelogic
I'm not
forums.
sure if that's there.
Do 3D
Might just be
printing
that
like
first
Thomas
equal
Lobach and Joseph Truss. There are also people out there who are well known for reviewing 3D printers.
Because this is too
Makers use
too quiet. So you have to take the screw all the way up to take out the big plate. Yes.
Yes, I remember. Oh, I
Yeah.
Ted and I talked about this. I don't know.
I
if
think you
there's
should
I don't
make
know if
like
there's
a-
prototypes to send them out.
To cut it out, so you can just unscrew a little bit and pull it out like the other machine.
Oh, why not?
You think about doing that?
I will ask our engineer to think about this one. You,
Yeah,
you
then
mean
you-
to the front, right?
Yeah, just cut
not-
out the.
just lose it.
Yes, or you can just lose it and pull it out. That's easier.
Will there be another meeting like this?
Man, I don't think it's that hard. I think it's easy to do.
More samples.
You're right. I'll talk to my orange.
So you don't have to squeeze it all the way.
Yeah, just a little bit.
Yeah.
Or would it be possible to come, I assume any new samples you're going to have, you're
I
going
don't
to
think you
put
can
up
do
on
that with the Titan.
Kickstarter.
Yeah, actually, one thing
I don't
that
think
we
you
forgot
can
to
do that
ask
with
people is
Titan.
like to bring your cameras to take pictures of these things. That
No,
we can get third
I
party
think it's
pictures of these. So,
Yeah.
I mean, we'd love to. I think
Yeah, I would
definitely
like
to
it.
have people.
I would like it that way, but
Okay,
You guys
okay.
put it
I
on
see.
so we can get
What
scale.
thing?
Yeah.
But this screw is shorter. It's only like this. It's shorter than the Titan.
still you have to.
Still heavy,
You
yes.
have you need two hands, right?
Yeah.
Or you just do one hand and pull it out.
Yes. Yes. Any more?
Thank you very much.
Thank you for coming.
I've backed it. I can't wait.
Oh, thank you.
All right. Thanks for coming. How many screws total are there that you would have to remove for the film?
The film, we're planning to lower the number. Now there are 26.
Right.
I think maybe 20 or 22 should be fine.
Right. Right. How long does it take for you to do it?
Oh, the film?
Yeah.
Oh, if it's perforated, it's very fast. You know, I would use a electric driver. It's very fast.
Yeah.
With like a little torque.
Let's see, question 70. I mean, we're doing 70 here just so that we can get this done in 2 hours, right?
Yes, it should be 2 hours. 2 hours, 3 minutes.
Yeah. What's the minimum height thickness you think you'll put in the software?
The height thing, we
Yeah.
can do, I think 10 micron, no
10
problem.
microns, no
Yeah,
problem.
no problem. This is limited by the mechanical.
Right.
Even you can do 5 micron, but it won't be accurate.
Right.
I think. Yeah.
So we're doing 70 now mainly so that we can get this done in 2 hours.
Yeah, well, I do 75 and a little bit under exposure
Yeah.
to accelerate.
Okay. Third-party software to print. I mean, the software's in the printer, right? So you can't really change the software.
That's a controlling software.
Right.
Controlling, but in terms of the slicing, the support, it's the third party.
Right.
You have to download it.
Right, right. So in many ways, you have to use third-party software in order to get the stuff ready,
Yes.
and then the printer takes care of its
Yes.
mechanical control through its internal.
Yes,
internal
the printer just take the
software.
slices.
Right.
And this printer is, I think, is even quieter than Titan.
Yes, it's much quieter than Titan.
Yeah. The resin, probably the box is smaller. And
I mean, it really depends on the stepper. I mean, I changed the stepper driver on my Titan.
Oh, that driver, yes,
And-
yes,
and,
yes.
And the driver makes a big
Yes.
big difference on the noise. Yeah, in order to smooth mine out when I made it, I,
0.2 millimeter, I think it just can make it because it's very thin. That's fine, but it's like almost like 1 centimeter.
no, in order to make mine spin, what I did was I power drove around right down until it fit every time.
So any
Question we need to.
Any more questions? Thank you for the answers. Okay. Any more questions?
Any more questions?
Let's see. This was the question on the number of screws, so we answered that. No more questions so far. Let's see. Do you want to show some parts while we're waiting for
Parts?
for the print? Some of
Oh.
the things that you printed.
Can we
Bring the parts over here.
Oh, bring the parts
Yeah, let's
over
bring
here.
the parts over here so we don't. I mean, people want to have like a. We don't want to disturb the view of the printer, so we want to kind of show these off to the side without interrupting the printer.
This one. Where should we put it?
So we
I-
can see this corner of the gear.
This corner?
Yeah, so we can see that.
Here.
You can see what's on screen here. If you look at my computer, it shows you what you're seeing. That's too far away.
It should be here.
It's gonna block everything. Where do you want it? Where do you want that? By your printer. I know.
So here are some. These are all from the top. From the beam, right? Which one's from the top?
This one.
Oh, time's
All right, we'll take that one away then. So if there's any questions about the parts, we can take questions on the parts and then bring them closer to the camera. Oh, the duck. Oh, you painted it.
Catherine,
Oh, Catherine painted it.
Catherine painted.
Yeah, full disclosure, it doesn't come with the eyes. Will there be an instruction manual?
Oh yes, sure. And we will have a tutorial video.
Yeah, so if you guys take a look at the other videos on Kudo 3D's channel for like the
And-
Titan 1, that's the kind of thing. That
Yeah,
they're looking for.
James actually did a lot of videos for Titan. So we might as well do something similar for the Bing. No, I think it's dropping. I think it drops. Yeah,
Big drop.
I think it drops.
How much did we get?
No, I think the first few layers dropped. Yeah, it drops. Yeah. Well, I think we have to do another one.
Okay.
Yeah.
Yeah. still dialing the settings on the prototype.
Yes.
No, this parameter is underexposed, so it's kind of it's towards the boundary or limit. If we do it, it would take some time to.
Yeah.
I think we can do
we
a.
only have 30 minutes left.
Mhm.
What do you think?
It won't be enough. This one takes 2 hours. Yeah.
Okay.
The maybe we can schedule another.
Yeah, we can schedule
There's
another
another streaming.
We have one more question here
Mhm.
about the uniformity. So it's not like DLP uniformity. There should be uniform out to the corners of the print area, the light intensity.
Oh, uniformity.
Yeah.
Yeah. It is. I think the surrounding is like 20% below the center. 20 to 25%.
So you mean like 75 at the side and 100 in the middle?
Yes, something like that. So when you want to use it, then you have to increase the 1/3 of the time to use the surrounding. So if we stop it.
Actually, no, we answered this question already.
Which one? I think we should do a live stream, something like a longer one, but just leave it there and.
This is the shipping question. I forgot to click it previously. But we answered the question. We're still looking.
Which one? The shipping question.
Yeah, that one.
Can
Let's see, I don't think there's any more.
some Jeremy asked the layer thickness. Oh, 75 micron is not the optimized thickness. This is 50 micron. This resin should be. So everything here is 50 except this is 70. This one is 50. This one is 75. This, no, it's not there. I think it dropped, and it dropped very early.
Okay. Two more
Let me see.
questions. Well, I think we answered this one before. Will there be resins that allow you to create objects which can be taken in the mouth, like a mouthpiece for a musical instrument? Right now, I think for standard acrylic resins, it's not recommended that you eat.
No,
You have contact with
only the biocompatible one.
Yeah. I mean, there are some companies that are producing no biocompatible resins, supposedly out of like PLA or whatever, but I think those types of like non-toxic photo initiatives are still pretty experimental, so we'll have to see.
Mm-hmm. The dental one might be
The
okay.
dental ones are used mostly for vacuum form. They're templates. You don't directly.
No, there's a biocompatible one. Yeah, and like a surgery guide, making surgery guide.
Then, so there was another question in terms of the uniformity. So
Mhm.
for something like this plate of rings where you printed everything
Yes.
all the way out to the corners,
Yes.
what did you have to do settings-wise in order to get the whole build plate?
Increase the exposure time and increase the lifting height because the cross section area is when it's getting bigger, it will take more time to separate. So you have to increase it higher to leave some time for separation.
Okay.
You don't need support between those bridge.
We're not sure because wants the successful rate to be higher. So you mean the support here, right? If you put the support here, the successful rate will be higher because this is like one object instead of independent objects.
Maybe
But-
under the bridge there's no support.
No, below.
I see the bridge is
You mean
quite
this?
long. Yeah.
This one.
Mhm.
Yeah, this is support too.
I mean, there's support under the bridge? No. I
No.
don't see it.
No,
Mhm.
no. So,
How can you print that like bridge that long?
castable resin will be difficult.
Yeah.
This is not castable resin.
Also it's fun with this.
So castable resin is very soft, so
Mhm.
it tends to.
Yeah, go
It-
like
it-
shaky.
yeah, it's yes. So, but for this resin, this is okay.
This is okay.
Yeah, and
That's pretty good.
so this resin is good for like high resolution forming, like miniature figurines. And this is a pretty good resin. But for jewelry, it's a different.
Yeah.
Yeah. So James, I think we will maybe schedule another one.
Okay.
But I would prefer something a bigger one, so it can. But it takes longer. We have to leave it there.
I think maybe that's the question is that the longer the live stream is, the harder it is for people to stay on and watch the whole thing. That's why it's kind of good to have, even if it's a smaller part, only like 1
Yeah.
centimeter or something, then we can do the whole thing
Let me see.
at
I
once.
think it drops the
Okay.
bottom. Yeah, it's not drop. Actually, just one layer. I think the exposure time's not nice. It doesn't stick there to it.
Oh, what were you printing? Yeah, I think you only managed to get about
A little bit.
a couple of millimeters.
A couple millimeter, yes. And then it's just does not stick well. It's underexposure.
Underexposed, I see. So then
Yeah.
it was.
Is that because it was going too fast or not bright enough? Or
It
what do
is
you-
also too fast. I normally don't do this speed,
Yeah.
and but we print this. Actually, this is the one. It's print out. It's like that. Then I don't know. I think this is just too close to the margin. Too
You
close
printed
to the
this the
boundary.
same speed, you mean?
Yes, this is let me see. You see, I left only like 1.6 here.
Oh.
I trying to push everything to the limit
Yeah.
because it's just too.
That'll get you.
Not for 2 hours, it's hard to get this, something out. And for this resin, it should be like 10 to 11 seconds. Push it down to 9. Usually high that would go above like 2. If it's speed 25, 30, it's okay.
So the first layer is a 5-minute exposure?
Yeah, to be safe, and
Yeah.
I think it's okay. It drops like 2 millimeter to 3 millimeters, so it's around think when it drops around 25 to 15, something like this. So there's a gap.
So okay, two more questions. First one was for this dental model, about how long did it take to print this?
This one? God, it's I think this one takes like 6 hours.
About 6 hours.
Yeah, this machine is not a fast machine, so.
And then there was a question about printing a figurine. You're still taking samples, right? So if people send you the
We're still printing, yes,
Right.
yes, and we try and organize it like in a way like if we show figurine today, then we'll take rotation. So we show different applications, and then we'll come back to the figurines.
Right. So the main thing for if you want TED to print a figurine is no copyright violations. So it's got to be your own work or Creative Commons, something that we're in the clear. TED will be in the clear to print. So if you're printing somebody else's designs or some other artist designs, then he won't be able to do it.
Can we show like can we have a close up something? Hey James, can we have like show close up like a surface? Can show them the surface or something.
It's harder with the webcam.
It's hard.
This one might be a little bit harder. Let's take a look. Let's start with the Kickstarter live and see how close I can get it. So there's often questions about the underside.
Mm-hmm. You mean close to the support?
It's always hard to get the close up on the webcam, so it might be hard. This is a better camera, the one on YouTube.
I think the film, when you leave it up earlier, the film like is loose and it's not like a drum.
Every drum is like that, but you can't really tighten it like a metal plate. That's impossible. So and it depends on the material. The Teflon actually has elongation.
Mm-hmm.
So when it's used for a while, it will become like stacking slightly, but that is not the really, we don't see much about that. Before you see a slagging, probably it will see like tiny dent from the supports.
Mm-hmm.
If you print a bigger area, like a circle, square, peel it slowly, the damage to the film is less than you have a lot of supports.
Mm-hmm.
You peel because supports has a force,
Mm-hmm.
and it tends to like poke the yeah. So it's more likely you see some a little bit like circles.
Mm-hmm. So the film doesn't have to be like very tight after you install it.
I think it's very tight. You can't really control it because when it's flat and that frame you screw it in, it already set the stretch it already, and there's no way you can lose it or very hard. So the tension actually is fixed.
We don't have to worry about the tension. That's
No,
what we do.
there's no way that you can tune it. After you lock it, then it's there already.
Can we take off?
Thank you for coming.
I'm a supporter.
Thank you for coming.
I'm a supporter. I was in the first 100 or so.
Oh, thank you. Thank you.
Thanks.
I think so.
So let's take a look at what's on the build plate. I mean, we still managed to print about half a millimeter, right? Or half a centimeter.
No, less than that. I think it drops when we drop the exposure time from 25 to 15.
So let's wrap up and let's show people what the process is, take it off, and then we can, there's still something there we can still deplate and to show the parts that came off. I mean, we were planning to print a small part anyway, given the limited amount of time we have. So maybe another time we do a place not in tech shop where we have
I think
we don't have the time limit.
maybe we should do something like in the office, do a regular print, and then whenever our backers have time, they just come back to check the status, something like that.
Yeah, so let's yeah. But I think for now you can show them kind of how we take off. I mean, because there's still some parts that have to
you
can take it off and see what it looks like.
I don't
Demonstrate the
have
process for us to close out.
So I don't have that. Usually we do the rubber, the scraper.
Scraper?
No, I don't think we have that here.
No, we'll just have to use paper towels today.
Yeah. And the actual build platform is bigger than this one. We are just borrowing from Titan. The actual platform is more sophisticated than this one. That comes with spring loaded. So whenever you push it down to the bottom, you'll make sure it will touch the LCD, and it won't tilt.
So is there an LCD under there that's curing it?
Oh, there's an LCD below.
Right, and that's what
Yeah.
cures the material as you lift?
Yes.
And does it cure it at that bottom layer then? At the bottom of the material?
There's
The bottom
Teflon.
of the fluid?
Yes.
So it doesn't come from the surface like a
No.
laser then?
No. The surface is.
So you have
yes.
to press that down against the LCD and
Yes.
then raise up and start curing
Yes.
from there.
Yes.
I see.
So.
So is it ultraviolet that's coming through?
It's just an LCD. So what?
Well, you got
you
light
got-
projecting
yeah.
through it, right?
And there's no calibration because the pixel size is fixed,
Yeah.
and you don't have focusing optics, so there's no focus. So you save a lot of things.
Contact print.
It's just contact. And the resolution is really actually pretty good if you check the.
I see it.
Yeah,
It's very impressive.
it's very impressive. Even we were impressed. So
What's the process that cures it? What kind of light?
it's just a purple 4 or 5 nanometer light, purple light. It's the same like color we use for the DLP. The DLP is a broadband. We have like 400 to 425, but this is only pure, like 4 or 5. It's just purple.
And is it?
So it only penetrates the solution just so far, so many thousands.
Yeah, and the resolution, because it's only 4 or 5, so the penetration is much lower, and which by nature it has a high resolution. And therefore, by nature, I cannot speed it up because if I make it too thick, it won't cure. Yeah.
Are you saying there's different kinds of resins?
Yeah, we're going to. We actually are testing them now. Some resin they are. This one is like the harder one actually. You have a softer one.
Like a flexible, softer, or like
not that. The
less
more like can do engineering, kind of. It's not like
malleable,
like
workable.
this. Yeah. And
You mean this is more brittle, maybe?
this is more brittle, but it's not. It's okay already. It's not the. And we formulate this because it's good for printing like like figurines, miniatures. But for engineering samples, then we might have to make it stronger.
When it's printing, is it essentially it's cured when it comes out of the resin immediately? There's no more curing that happens after the process is finished.
You don't have to fix it later.
Oh no! After it's done, you still have post cure it.
Oh yeah.
Yeah, I have to clean it. Usually that's for the surface, Otherwise,
Is it just
a
for
little bit
cleaning?
sticky. No,
Oh.
if you don't post cure the surface, sometimes it's a little bit
You
sticky.
cure it with light?
Yeah, just the sunlight or this light. If you leave it here under a day or two, it will dry.
These look like fluorescent, but they're actually LEDs.
Are these LEDs?
Fake fluorescence.
Okay.
So it's similar to ultraviolet light curing methods.
Yeah.
I don't know what the frequency is, but it's ultraviolet and purple is pretty close, right?
Yeah, so we will schedule something else to be printed, but probably a longer one. Something that we can see, So the first 2 centimeters or 3 centimeters, you can see anything here.
So why don't you work on something that you can put different colors mixed together and have different wavelength cause different ones to cure so that you end up with color? Yes?
I think the color is not part of the process.
I know.
It's
but
an additive to the resin.
I'm saying this is something to think about later.
Yeah, but
You,
it's
you can mix all of it together because black has all the colors.
Multicolor
But if a certain
SLA.
frequency will cure red and a different frequency of light will cure
they
green.
laughed for FDM multicolor too.
And the curing are kind of two separate things. I mean, there's not that many different types of photo initiators, and the 2 or 3 common photo initiators for this are all in the
Just interesting.
395 to 420 nanometer range.
So is the actual resin is clear?
Depends on the kind. So the most common one, the fastest one used for these 405 nanometers, they're slightly yellowish because they absorb up to somewhere around 420 or so nanometers. That then cuts off the blue end, so the thing looks a little bit yellow tinged when you use it.
So how do you get it off?
Oh, this one, we usually just use the blade.
Okay.
We have a blade. Yes, I think. There's
Do these still come off? Are these still removable at this point?
Yeah,
after it's been this cured?
I mean, sometimes depending on what you want, you might post-cure it on
Yeah, I know, but that one's wet.
on the plate. So for instance, on the Titan 1, one of the users, one of the early Kickstarter backers who uses the printer extensively, runs a machine shop. And what he does is he prints out parts as previews for his customers to validate the mechanical shape of their parts before he cuts them in aluminum. It's a lot less effort to set one of these up to print than it is to set up a cam path to cut something in
metal.
in aluminum, like out of Tormaki or something.
And cheaper too.
So
right?
it's
In
some-
terms of the
something
materials.
like-
I mean, aluminum and steel are pretty darn cheap, but it's time consuming. It takes way longer, and so you just print something.
Yeah,
so
and
he
just
did
use the
that.
blade.
And so for him, he has a whole process, a post-curing process, with some things that he designed himself to maximize the linearity of the parts in post-curing. So he designed
The linearity of the part or the curing?
For
the
one of his
parts
clients,
stretch?
and on our forums, you could take a look. He posted pictures of it. He had to print these really, really long, like probably 10-inch long rods that were really, really thin. And so he designed a post-curing mechanism that has like sets of LEDs all around the perimeter, and he's got a rotational thing that rotates the part in order to make sure that it's fully uniform, to keep the part from warping because it was so long. I mean, those are pretty unusual parts. I mean, he's definitely on one end of the use
So-
case printing parts like that.
Right after printing, there's still some flexibility in it before it's cured
Yeah,
completely.
you can feel the difference. Is if you look at what did we just print out, right? If you feel
It's wet.
Yeah.
it's a little wet, but if you feel how flexible this film is, just the film, right?
Yeah.
And compare it to how flexible that guy is, right?
No,
It's brittle, right?
It brittle.
Yeah,
After
yeah.
it cure,
Because
get
after you
cured
post-cured, it gets significantly harder.
Yeah.
So that's what you're looking for in the part.
Is there anything you can wash the resin off with at this point instead of drying it?
Usually we just drop it in the alcohol.
In alcohol.
Alcohol?
Alcohol, like 2 minutes,
And that won't,
Clean one.
that doesn't
and then
interrupt the final process, the final curing or anything then? Doesn't react.
That's before the post curing.
Right. So,
So once-
but that doesn't
yes.
damage, that doesn't affect the part
Oh
otherwise.
no,
it just gets the
you
goop
could
off.
damage if you soak it for too long.
Yeah.
Yes, it could damage. So maybe like 2 minutes, 3 minutes, that should be fine.
How long does it take to print something this tall?
This one I think 9 hours.
And since
9
you're
hours.
doing it all in parallel, then
Mhm.
all your time is in the height, isn't it?
Oh yes.
Because it doesn't take you any time to go. If it's
Not
if it's
X, Y,
wide
it's
like
Z.
this,
It
right?
is Z.
Yeah. So this would.
Yes.
One of these would print just as fast as all 80 of these, right?
Yes. It's the layer.
It's the Z, yeah.
It's a Z. One layer
That's
takes a
interesting.
lot of time.
Yeah.
There's got a few more questions. First question: how does the bed leveling work?
What?
Bed leveling.
Zero, your zero sensor. That's
Oh.
different from that we have here.
This this is a zero sensor. It will stop. If I press the home button, let's see. I can move it a little bit higher. Okay, now if I press the home button here, it should go to 0. You'll go to 0.
Right.
But
and so you
but
have a piece there that then is
Yeah.
calibrated to trigger that.
so if
You can
I
wait for it to trigger by itself. We don't have to do it manually.
that's fine. You can see it. It stopped.
Right.
Once the light is blocked, there's a line infrared, I think, or
Right.
visible. Then it will stop. And there's a blade here.
So on your spring platform, where you said it presses very well against the bottom, you have to.
That will absorb arrow.
Right. So,
Yes.
So you get this, but you zero that in with this blade for the homing.
No, the
And-
blade is just for demo. You don't.
Oh, you don't even.
Yes.
No,
Yeah.
no, I mean
Just
this
show
one.
you.
I mean
that.
this tab.
Yes. And
You have to calibrate the platform with that tab.
and then it's also give like of insurance. If there's error,
Yeah.
means that if you have a spring, press it won't damage your LCD. So if it's not 100% level, then this corner may be sharper, and then you squeeze it in, and it might damage. So it gives one more, level of security.
Do we have leveling screws automatically?
No, usually we just when we do a calibration, we just press this down a little bit, then this will be flat, sitting flat on the LCD, and it should be very accurate. It should be very
Set
accurate.
it down very flat, and then you set
Yes.
the off
Is
position.
that why the gimbal? That's what the gimbal does.
Well, I think that's because this is not the end product. Is that what you're
No,
saying?
this is the one in Titan. So actually, this one is a little bit more advanced than Titan. We haven't put it on Titan yet, but we'll soon do it. And this one will have those spring loaded, but for Titan we don't have that because the vat for the Titan is soft.
This is a ball, so this should rotate to make it even with the bottom.
Right, but this isn't their normal attachment.
I see.
What kind of what kind of file format do you render files in?
Getting into the printer, it's just pure slices, PNG slices, and wrap into a zip file. And that's it. But before getting there, they need a slicer and to process all this thing.
And slicing must be very fast.
Slicing, or it depends how many layers you want to slice.
Yeah. Well, and high resolution, of course, means lots of layers.
Mm-hmm.
What's the vertical resolution between layers?
Usually we do 50 micron for this resin.
Oh, it varies by different resins.
Yes. And but most likely it's 50, 25, 50. It's fine because this wavelength usually would get absorbed quickly, like 30 micron, 50 micron. It absorb. It go to 75 or 100 decays very fast.
Yeah, because for the photo initiator that's commonly used here has a absorption peak right around 405. So the photo initiator itself will act as a light blocker. It'll absorb the light energy from going through.
Yes.
So that's in some ways why this is a little easier than like DLP, because DLP is like broad spectrum.
Yes. So even without a UV blocker, this photo initiator will absorb light strongly with at 4 or 5 nanometer.
So if we had fluorescent lights in here, then this would be
You'll start curing. You'll start curing.
Is that what the hood is for?
Yes.
Yeah.
Yes.
Or a hood that absorbs 450 millimeters, right?
And then, one more question.
Mm-hmm.
You're printing the whole build plate, like those rings.
Okay.
Is there, by increasing the exposure to get the corners to print, was there any impact on the resolution in the center? From getting more exposure?
Actually, on the Kickstarter, we mentioned that in this, there are numbers on the first the Kickstarter front page. There's some deviation, but it's very tiny. I think 5%, around 5% deviation. We measured the size of the plum,
Right.
and the surrounding is 5% smaller than the center.
I think that's all the questions we have here. We're reaching the end of the 2 hours, and then we'll do another one.
Yeah,
Maybe we'll do it. Next one we can also do it later in the day.
Yes, I think we should do one like it's already half done or something.
Yeah.
And
Well, also because we have so many Japanese backers, if we started like around 5 o'clock here, then it'd be easy for them to join. We can see that some Japanese speakers have only just joined because now it's like 8 o'clock in the morning.
they're morning, just wake
And
up.
So, and so maybe do that.
Yeah.
Maybe they can help us maybe do a chat.
Oh, yeah, that's good.
Okay. Does the PC need to be turned on during the entire printing process?
You
No,
can
right?
remove the PC.
Right.
And
so the file, the data is sent to the printer,
yes.
and then the printer just prints itself.
Yes.
And the PC turns
Yeah,
off. And takes away.
once it's uploaded to the printer, you can use your cell phone to control the printer to start the print or move it. It's no problem. And those are all remote devices. You can just remove it once everything is set inside the printer.
Okay. That's it. All right. Somebody actually has the meeting room at 5, so we'll have to shut down now and clean up.
Thank
and we'll do
you.
another one.
Yeah,
let you know.
we'll
Thanks.
do another one. Thank you for joining. Yeah, any question, just leave a message or put it on the comment. Thank you. Have a nice weekend.